Hello, everyone, and thank you for joining us today. We'll get started here in just a moment, but before we do, I'll go over a couple housekeeping items. During the panel today, you can submit your questions at any time into the Q&A box, and they will be addressed at the appropriate time. If you experience technical issues, submit those into the Q&A. I'll address those immediately for you. So with that being said, I'm going to go ahead and hand things over to Catherine Nyambala to get us started.
Thank you, Cameron. Good afternoon, good morning. Welcome to the Power Africa USAID EECA Charging Ahead for East and Central Africa. We are going to be discussing the role of battery energy storage in the access of quality and reliable energy. Let's start with some statistics. If you look at East and Central Africa, you find that more than half do not have energy access in terms of each of the country's populations. If you look at the graph in front of you, we have Rwanda at the highest with around 98%, 88%. And then we have Tanzania following at 78%, Kenya at 77%, Uganda, and then Ethiopia. From Ethiopia on, none of the countries have their population having more than 50% energy access. That is the state of affairs in East and Central Africa. Now, our program is doing something about this. We have the Power Africa, Empower East and Central Africa, whose goal is to increase the availability of and access to affordable, reliable, sustainable, and modern electricity in East and Central Africa. Ladies and gentlemen, the first development objective is to end energy poverty, which works towards enabling increased access in on-grid and off-grid connections, as well as supporting employment opportunities and improving energy access for marginalized populations. Under development objective number 2, we have accelerating a carbon-free future, which looks at how to increase the megawatts capacity, the installed capacity in all the 14 countries, as well as looks to support the national and regional planning for energy transition, where we look at new transmission lines and cross-border power trade. In the third development objective, we bolster energy sector investments and innovation. And here we are looking at leveraging public and private funds for the on and off-grid energy sector projects. We are supporting improved private sector delivery of energy goods and services, strengthened enabling environment for energy sector, and increased investment in and utilization of advanced energy technologies, as well as a socially inclusive and environmentally responsible energy sector. Those are the development objectives of Empower East and Central Africa. This afternoon, we are going to discuss battery energy storage systems. There has been an unprecedented increase in the installation and deployment of variable renewable energy. In front of you, I have captured the largest wind project in Africa, the Turkana Wind, at 310 megawatts. And then we have all manner of other wind and solar projects, and more coming up every day. I have an interesting snapshot here of how battery energy storage systems can be deployed. And this I found in the IEEE Open Journal of Industrial Electronics Society. Battery energy storage, as you will hear from our panelists this afternoon, have very many use cases. But it's interesting to note that the use cases range from very short milliseconds usage to long hours. At the very short milliseconds end of the spectrum, you have the power-based services, such as harmonics, mitigation, and islanding, and all the ones that you can see in the orange color, which also transition to short seconds and medium minutes. As you move to medium minutes, you have power and energy-based use cases, which include primary frequency control, secondary frequency control, black start, and load smoothing. When it comes to long hours of battery use case, then you have the tertiary frequency control and congestion management, amongst others. These are very interesting graphical representation of how you can use battery energy storage systems from very short milliseconds all the way to long hours. You can learn more in that journal. Ladies and gentlemen, you'll be interested in knowing some fun fact about some of the biggest battery energy storage system plants in the world. The largest system in the world today is in California, USA, the Edwards and Sanborn Solar Plus Storage, 3,287 megawatt hours energy storage. This was completed in January 2024. The largest battery energy storage system in Africa right now is the Kenhardt in North Cape, South Africa, Kenhardt Solar Power Complex Station, 3 180 megawatt solar PV plants combined with storage, peak power of 225 megawatts alongside 1,140 megawatt hours commissioned in 2024. According to the Bloomberg New Energy Finance, the expected global demand for BESS in 2030 is 400 gigawatt hours. Think about that number for a minute. What is the total installed capacity in Africa? So in the world, we're looking at 400 gigawatt hours by 2030, 5 short years away. And so we decided that it is worth the conversation. This week, Power Africa EECA is running a training for the entire energy sector in Kenya, right here in Nairobi, Kenya. And we have participants from every major state-owned entity in the training. And if you look at these numbers, the numbers that I showed earlier that has been put together by the EECA team across the 14 countries on the state of energy access vis-a-vis population, you look at the continued injection of variable renewable energy onto the grid and the anticipated capacities, then we thought this was worth a discussion so that we can share some insights into some of the way forward that can be adopted. We are going to talk about the technical aspects of battery energy storage systems, applications and use cases, legal and regulatory aspects, economic and financial analysis, funding, and the future of BESS. To help me in that discussion, we have Scott Edmonds from ECA, Anthony Mboro, an industry executive and CEO, Engineer Nixon Bukachi, a senior policy officer and Tobias Datman, who's one of our trainers today in the BESS training from Inanex Chelsea. Ladies and gentlemen, tighten your seatbelts and let's dig into it. They have a lot for you. Okay, let's get started then. That was the intro on what we are going to go through this afternoon. So I'd like to get us started by asking our panelists to introduce themselves. And we're going to start with Anthony Mboro. Anthony?
All right. Thank you, Catherine, and good morning, good afternoon to all the attendees. My name is Anthony Mboro. I'm currently CEO of DPA Africa, DPA Kenya. This is a subsidiary of EDF. We are in the financing, development, and operations of energy plants, renewable energy plants for commercial and industrial customers. I have been involved with battery energy storage in a previous life. I spent about 3 years with Tesla Inc. As a business development lead for energy storage in East and Central Africa from 2018 all the way to 2020. I may have interacted with some of you in some of these endeavors and in some of these projects. And glad to be here and to contribute to the topic today about how we can really support increasing reliable energy access in Africa. Thank you.
Thank you very much, Mboro. Asante sana for the intro. And as you join, welcome everyone. I can see now we are at 1:40. Thank you so much for joining us this afternoon, this morning, depending on where you are. Please put it onto the chat box where you're joining us as we continue progressing the intros. Next up, I would like to invite Scott to introduce himself. Scott.
Hi, good afternoon, everyone. So I'm Scott Edmonds. I'm a managing consultant at Economic Consulting Associates. I'm based in London, UK, although we also have offices in Greece and Thailand. So ECA, just as a brief intro, we provide specialist economic and regulatory consulting services across the utility industry. So we advise governments, investors, and regulators, and our experience has covered over 100 countries worldwide. And that has included multiple least cost energy planning studies across sub-Saharan Africa. Me personally, I work across ECA's markets and economic regulation teams. So I have an economics background. And that means we've been increasingly looking at all the different economic and regulatory issues that surround the integration of renewables, and of course, then evaluating the economic case for battery storage systems. And just for a few different examples of some storage projects I've been working on lately. So one, notably, I was working on a study with the World Bank, advising the Ministry of Energy in Kenya that was looking at the potential for BESS to utilize the excess geothermal capacity in Kenya. Also recently been working at some long-term energy storage projects in a Western European country, including looking at analyzing the economics of network charges for storage. And also recently been looking at the economic case for a proposed battery project in Southeast Asia. So definitely crossing across the world there. So thank you, everyone.
Thank you very much, Scott, for that introduction. Yes, I met Scott in that work on World Bank battery energy storage for Kenya. Let's move on to Engineer Nixon Bukachi. Nixon, please unmute and introduce yourself.
Thank you, Catherine. Good morning, good afternoon, everyone. So my name is Nixon Bukachi. I'm a senior policy officer at the African Energy Commission, which is a specialized technical agency of the African Union. Previously worked in the Kenyan regulatory space, focusing mostly on renewable energy and energy efficiency. Part of the team that was working with the Scott from the government side to support the work on battery storage in Kenya, and also been involved in a few projects before the meter that support access to electricity using battery storage, and happy to join in this discussion today. Thank you.
Thank you very much, Nixon. And last but not least, Tobias. Please, one of our trainers in the battery energy storage training, please introduce yourself, Tobias.
Yes, hi, Catherine. Hope you can see me and hear me. Yes, my name is Tobias Erdmann. I'm a consultant from Germany, doing the training here since Monday for this week in Nairobi. So I've been working in the field of energy storage for about 18 years now. So my original background is pump storage technology, and this is still the area that's fascinating me most. But so started as a mechanical engineer at one of the biggest operator in Europe. So in the field of the pump turbines itself, then it was about the use of optimization of pump storage, then getting into areas of balancing energy, optimizing machines, going into the day ahead and in the intraday trading. So at one point I came across batteries by chance indeed. So simply because of the extremely high level of dynamic growth in this market in the recent years. And yes, I mainly work international in the development cooperation projects. So often involves with questions, what is the better technology, pump storage or battery? So my answer is always, it depends. So yeah, happy to be here and happy to answer your questions.
Thank you so much, Tobias. So ladies and gentlemen, those are our panelists, and we're now going to go straight into learning more about the projects they have been working on. Please put on the chat where you're joining us from. We'll appreciate that. And thank you so much for joining us once again. Let's start by talking about some of the projects that you have been involved in. And let's start with Anthony Boro. I know you're previously at Tesla. Please tell us about some of the projects you have been involved in. Today, we are focusing mostly on the utility scale energy storage, but we can also talk about other C&I projects. Anthony?
Thank you, Catherine. Great. So I have been involved in developing a couple of projects, some which are live today and some which haven't. I think we were really focused on doing the front of the meter utility scale projects in East Africa. And today, this hasn't been achieved yet, though lots of strides have been made with that respect. But we did a couple of projects. I think at the microgrid level, we did a 2 MWh battery project in the DRC, in the Eastern DRC, that was with Nuru. Some of you may know Nuru, then used to be called Kivu Green Energy. That was a microgrid focused on energy access to displace diesel and just help integrate solar and minimize the use of fossil fuels. So that was great. That was in DRC. On the commercial industrial space in Kenya, I did develop and we did implement a 1.5 megawatt PV and a 4 megawatt hour battery storage system with Williamson Tea at one of their factories. This was an interesting case for diesel displacement because as most of you know, if you're from Kenya, that in the western side of the country, we do have fairly unstable grid. And as a result, this factory was actually using about, diesel for about 70% of their energy needs. So there was an interesting business case then to displace diesel with solar plus storage. So yes, those are some of the two key projects that I did develop and actually are live today. We did a few more. We had a few projects, of the islands in Seychelles. We had a few projects in Tanzania. We did do a couple of off-grid mini grids in Kenya at some of the high-end tourism facilities. We also did a couple of mini grids in South Sudan. So quite a number of projects that we did earlier on. I know today the deployment of battery storage is a lot more widespread than it was then. And so quick rundown of some of the projects that I've been involved in today. Even at DPA, I'm still involved in financing a couple of commercial industrial battery scale projects. And we can talk about those later. Thank you, Catherine.
Thank you so much, Boro. Before I let you go, what do you, our audience is varied. What do you mean by front of the meter or back of the meter? just in case.
Yes, thank you. Yeah. So front of the meter means literally on the grid or before you get to a customer's premises. So any of the applications of batteries before you get to a customer premises meter. So that's front of the meter. Behind the meter means literally any application of energy storage behind a customer's meter. And that could be for many reasons, as we discussed shortly. It could be renewables integration, could be diesel displacement, could be backup, and so on.
Thank you very much.
Thank you.
Now we know what front of the meter and back of the meter means. Let's move on to Scott. Scott, any projects that you have been involved in? I know you've already mentioned the World Bank study.
Yeah, I guess I'll start with that one because that was a fairly large one we did there. It was quite a unique case. So, well, obviously, a lot of discussion about how to best integrate renewables. In Kenya was an interesting case where there's currently some excess geothermal capacity being generated overnight and flexibly. So we were looking at, well, what's the potential for energy storage to kind of capture the value of that excess energy. So it was a multi-phase project. We were looking at the legal and regulatory landscape. There's I think we'll be touching on this later, but there's a number of different regulatory questions that need to be explored as you start to look into BESS potential. Our study also did some least cost generation planning. So I mentioned ECA. We've done a fair number of least cost energy planning studies. And then we paired that with some hourly dispatch simulations to try to identify, well, what is the best use case for BESS in Kenya. So it's not just a matter of simply energy dispatch. Often there's another component, which is providing services to the grid. So providing reserves or ancillary services. Our technical partners on that study, WSP, they helped us with a technology overview, looking at the latest storage technologies for that study. Finally, we were looking at designing different commercial options or models for BESS. So what kind of contractual matters are needed for signing BESS. So that could be if you have a tolling fee or a fee that is based on capacity available. There's a few different options there. And then we also looked at the economic case for BESS. So we were trying to take into account all the CapEx involved, potentially deferring network investment, the running costs, the carbon emissions, adding those all up and try to see, okay, what is the economic case for BESS today? And then secondly, I'll just add that there's another project we've been looking at recently. This is in Western Europe, and it's a very wind-dominated system. And it's very much a debate about what are the appropriate network charges for storage. As often there'll be some debate about, is it really appropriate to charge the same network charges for BESS or storage technologies as you would for a traditional generator? If that BESS technology is also aiding the grid by helping you avoid or defer some investment. So if you've placed the BESS in an optimal spot on the network, you're actually aiding the network in ways where perhaps there could be a case to be made for giving them a discount or waiving their network charges. So, yeah.
Thank you, Scott. Sounds like the World Bank project was cutting across almost the full spectrum of the possibilities on BESS.
Very
Let's
much
move on
so.
to Nixon. Absolutely. Thank you, Scott. Nixon, any projects you've been involved in, and you can give a different perspective of the World Bank BESS, because at the time you were working with the regulator in Kenya.
Yes. Thank you, Catherine. So basically, I've been involved in the space from the regulatory perspective, trying to look at how some of these projects fit into the energy mix. Initially, mostly in the off-grid space, where we're trying to promote the use of the off-grid systems, the solar home systems, and mini grids in enhancing access, and where, of course, then batteries come in very strongly, involved in design of a few of the mini grids in Kenya, sizing of the battery capacities that are being used. But then as part of the government side that was looking at the study that was being done by ECA, trying to look at what are the various options that are available in terms of integrating the use of BESS in the utility side of the network. So that time I was able to do quite a bit of research around this topic and what is happening at the global scale in terms of development of BESS at its utility scale. And that's what I think I'll be able to share as we progress going forward. Thank you.
Thank you very much, Nixon. Last but not least, Tobias, please share with us some of the projects that you have been involved in. You've told us about quite a number, and I'm sure the audience would like to hear.
Yes, so I think the project we spoke already about the last 2 days was the two major projects I was involved in regarding large-scale battery was one project in Georgia that was the first grid scale, or is the first grid scale BESS system in the power grid. It's about a 200 megawatt system with a 200 megawatt hour storage duration. So quite an urgent project because the system is really quite unstable, running out of frequency reserves. So I was supporting this project regarding the technical specification, regarding the tender documents, and regarding the general layout. So it's still in progress and still quite learned a lot. One of the biggest projects even in the European continent. So it's all about frequency regulation, stabilizing the grid. It's a lack of reserves in the positive and in the negative direction. We set up a quite large model, quite large black source modeling. So I just supported them. I did it on the technical side. So economics play a big role. So the prices are falling still. So economical numbers in the business model changing nearly month by month. And yeah, it's a lithium-ion project. And another second similar project is a project in Sri Lanka, also first large grid scale in the system. So they had the problem of limited renewable energy integration at this point, also lack of reserves, frequency reserves, secondary reserves in the dry season especially. So they're losing hydropower units in the dry season for regulating the grid. At the same time, rising demand, strongly rising demand. And yeah, the same issue here. They need a stable grid. They need more frequency reserves. And this is about a 60 megawatt, the very first in the planning. So they're planning much more. And yeah, it's quite interesting to see how urgent this is for the TSO. And really will be happy to have this on the grid and keeping the system at least in the first phase stable, and then having a look at integration of renewables and looking for another phase.
Thank you. Thank you, Tobias. Projects in Georgia and Sri Lanka. Amazing.
Yeah,
200
correct.
megawatts hours.
Yeah, it's quite large.
Yes, that's quite something. Now, let me just a reminder that please use the Q&A box to type in your questions and comments during the panel discussion. We are going to run through the panelists with the different topics we spoke about, and then they'll be able to respond to your specific questions. Let's get started with some of the insights. First up, I would like to invite Anthony Boro to tell us more about BESS deployment. We have different people in the audience, and some have been working with this, some haven't. Anthony, why should we be focusing on BESS? Why should we deploy BESS? Why is BESS a solution?
Oh, thank you. I'm hoping that by now everybody is converted that BESS is a solution for us. If we are to keep global warming below 1.5 degrees as per the Paris Agreement, as per targets, we definitely need to look for low carbon energy pathways. And I think renewable energy is really one of the key solutions we have to solve that challenge. And as it was mentioned a little bit earlier in the conversation, the moment you start to have a significant amount of renewables on the grid, then you start to run into stability issues, mostly due to the intermittency of variable renewable energy. and hence BESS becomes, or not just BESS, but energy storage in general as a technology, becomes something that you actually need to work with or to integrate. When I look at the Power Africa objectives for East and Central Africa, whether it's ending energy poverty, accelerating a carbon-free future, whether it's strengthening and expanding grids, and basically also bolstering energy sector investment and innovation, I see a thread, that can be tied together with energy storage, and BESS works pretty well across all these three themes. Without going too technical into it, I can quickly just talk about a couple of ways batteries or energy storage can assist on all these pillars. So if we're talking about ending energy poverty, we know that we saw the statistics on energy access. We know that in a lot of places in sub-Saharan Africa, access to reliable, clean energy falls way below the thresholds that are needed, as per various human development indices, and really to help us slow down global warming. You can integrate batteries with solar in an off-grid scenario to really enable energy access. It is for places where it is expensive or it is not feasible to extend the central grid to, either because of the loads are low or just a geographical dispersion of the demand doesn't really make sense for us to extend the central grid. If we do talk about accelerating a carbon-free future, this is one particular area where battery storage shines quite a lot. And just to step back a little bit, batteries can be used both for power and energy applications to really enable a carbon-free future. Top of my mind, I can think about if you really want to farm up renewables on your grid, if you want to integrate wind, solar, and other variable sources onto your grid, you want to avoid curtailment. You do have a couple of large plants on the grid. Let's look at the case of Kenya, where you have one of the largest wind plants, Lake Turkana, 310 megawatts, sitting quite a bit of a distance away from the load centers. And if you want to avoid curtailment of Lake Turkana, and I know the other panelists have talked about some studies that have happened in Kenya to really look at integrating renewables, then you can store energy when it is not being needed. And that way you can also increase the capacity factor utilization of these plants. You can avoid deemed energy payments. I know in this part of the world, we have a lot of power purchase agreements being take or pay rather than reverse auctions or take and pay. So that makes it interesting to deploy batteries from an energy perspective to store energy when it is not needed and use it when the grid needs it later. So literally you're shifting the energy demand and trying to match the energy production and energy demand, avoiding curtailment and really economizing on dim energy charges and the like. I think the other thing that application of battery storage that is interesting for integrating renewables is literally on enabling the dispatchability of renewable power, whether it's wind or solar or the like. We know the intermittent nature. Sometimes it's not easy to plan ahead to know how much power you will be able to generate from, say, a wind or a solar plant a few minutes in advance. But when you do pair that with a battery storage, then you are actually able to convert that plant into a dispatchable plant, which is quite highly valued. There's lots of arguments and discussions on how do you actually compensate or how do you value dispatchable renewable energy vis-a-vis straight intermittent renewable energy, but maybe not a conversation for now. I think when you look at another way you can accelerate a carbon-free future, we know that on most grids you do have pickup plants, which generally tend to be either gas or HFO, pretty much fossil fuel fired. And this really come in different times of the day to really support the grid performance, grid reliability. batteries can help that. They can ramp up way faster, than either, gas or thermal plants in general, while still being clean, and especially where they are paired with a renewable source of energy, you really help to reduce the carbon footprint of your electricity grid in a particular geography. Batteries also quite good in providing ancillary services. I know there was quite a number of mentions, whether it's frequency control, voltage control, black start. The batteries can come in very useful to do that. You can deploy them fairly more quickly. I think case studies have shown they are actually more economical. They actually technically perform better than a lot of other resources that are used as peaker plants and so on, or to provide ancillary services to the grid. We know that in a lot of the places we have challenges with our transmission and distribution infrastructure. So strategically placing battery storage on the network can really alleviate congestion or lack of capacity at substations and the like, and can really support the grid's performance. And that's another way that we can deploy batteries. One other way we can also deploy batteries that's actually useful for us in accelerating a carbon-free future is really looking at renewables farming, whether it's ramp rate control, whether it's being able to forecast with accuracy the amount of power that is available to the grid. So for energy planners, network planners, that could be a very useful functionality that you can get from battery storage. So just a summary of some of the ways that we can do that. We can even talk about things like providing non-spinning reserves. So I think Scott did mention something about looking at the possibility of using energy storage to provide spinning reserves or non-spinning reserves to replace the use of either geothermal or thermal or hydro on the grid. So another interesting use case for us. So I think when you look at all these applications, and I've just really summarized a few that are possible, you can really start to see that batteries in supporting a low carbon energy pathway can be quite crucial. And they do work well where you have low cost energy available in the market. They do work well where you have a high penetration of variable renewable energy on the grid. They do help a lot where you need to manage peak demands, whether it's from a T&D perspective or from based on the energy load profile of the country and so on. So in summary, that's a quick snapshot of some of the ways in which battery storage can be useful and why we should all be convinced and bought onto the idea of energy storage deployment on our grids. Thank you.
Thank you so much, Anthony. Thank you so much for that comprehensive answer on deployment, frequency control, voltage control, ancillary services, black start, T&D, deferral, and pickup plants, and more. Thank you so much for that summary of why someone should deploy BESS. Now, having had those applications, let's talk about the technology itself, the technical aspects. And one question that is often asked, can you compare battery energy storage with other storage systems such as pumped storage? To help us understand that comparison and the technical aspects, I'd like to invite Tobias, who has actually rolled out a number of projects. Tobias, please break down for us some of the technical aspects of BESS, and in particular, compare with other storage options. Tobias?
Okay, yes. So as already mentioned in my introduction, so I started in the field of pumped hydro storage technology around 20 years ago. And at this time, this was the only storage technology that was really truly economical and at the same time widely used in the energy power system. So it had been the case for more than 100 years. So the oldest pumped storage I was working in are over 80 years old. So, and even at this time in the early 90s of the last century, the power installed was nearly over 100 megawatts. So why should this change if it works so well for so long? And 15 years ago, the cost of batteries were about 10 times more expensive than today. So at this time, nobody was thinking about having battery systems as large-scale systems in the power grid doing the same what pump storage doing. But as we see, time has changed, so has my view. So right now, just an example, in Germany or in many other countries I worked in, almost 100% of the frequency regulation is now covered by batteries. And 20 years ago, it was completely the other way around. It was mainly covered by hydropower or pump storage power plants. So a complete shift in the last 20 years. And if I should compare these both technologies right now, because they're both the fields I'm working in. So what is the technology storage of the future? So my answer is both. So quite different type of technologies and quite different types of duration at the moment. So it's quite clear that batteries in the short term and in the frequency regulation are by far the dominant and competitive storage technology. But I'm quite sure that pump storage will play an important role in the middle and in the short term for long, but also in the long term. We have not seen so many pump storage projects at the moment worldwide in planning and in construction. Just in China alone, we have 30 gigawatt pump storage projects under planning or just finished. So it seems not to be the technology of the past. And yes, I would make a difference in the usage in the short term, the time of usage. So batteries up to 3-4 hours are quite not compatible. And yes, pump storage with around 4 to 12 hours in the average 8 hours simply have the capability of really storage large amount of energies. And of course, looking at the lifetime span of 80 years or more, the feasibility in this range is really also not really not beatable. So of course, battery will be the far biggest storage technology regards of power and regards of storage capacities in the gigawatt hours. But I think there will be a little space for the pump storage, at least regarding the long lifetime of 80 years. So you will see them in 15 years, I'm quite sure. So you need both, and I think a perfect match working together as a hybrid storage system.
Thank you, Tobias. Thanks. So pump storage is still key, but BESS is overtaking that. Now, Nixon, let's talk about a just energy transition. We keep hearing words like just energy transition, sustainable energy. What is the role of BESS in sustainable energy? I know Anthony has already given us some of the reasons for deployment, but give us a perspective that takes into consideration just energy transition and sustainable energy.
Thank you, Catherine, for the question. And it's true, Anthony has given a good overview in terms of how we can be able to utilize BESS in the various applications. But then I will take us back and try to look at it from a continental perspective and also look at the different circumstances that we face. For example, in Africa or different African countries, we have countries which have fossil fuels, significant deposits in terms of natural resources. We have countries that do have renewable energy sources on the other side. And globally, the objective is to be able to transition all the countries to a net zero future. So basically, whether you have wind, whether you have solar, whether you have hydro, geothermal, and all the other resources, including coal and the likes and natural gas. But then these resources are finite, and countries are looking at how we are able first to ramp up access in the continent. So therefore, it means that our growth in terms of electricity demand will continue to grow both in the short term and in the long term, maybe up to 2063. If you look at Vision 2063 of the African Union, where we are looking at developing most of our economies so that we're able to support most of our population. So it means as we continue to grow, we continue to industrialize with urbanization, we expect that there will be growth in terms of demand for energy in aggregate. But then as we do this, we move towards this growth path, we're also supposed to start looking at how we are able to decarbonize our energy systems. And in this case, for us to be able to decarbonize and also not only decarbonize, also be able to diversify our sources, because you realize there are countries within Africa, for example, which heavily rely on hydro generation. But then over time, we have seen with the changes in climate, there is need for these countries to be able to diversify. Also, there are countries which are heavily reliant on fossil fuels, which need to decarbonize. So aggregating this, it means we have to use our available resources at continental level to be able to meet our energy demand. And when we are looking at these sources, we'll be looking at wind, for example. We'll be looking at hydro as an example. We'll be looking at solar. We'll be looking at geothermal. But if you look at the resources like hydro, geothermal, these resources are constrained in terms of the available capacity. In the continent, we're talking about 350 gigawatt hours of hydro, for example. We are talking about around less than 20 gigawatt hours or gigawatts of geothermal. So it means what we have in abundance for this case is solar and wind. So as we try to decarbonize, as we try to electrify, we expect that these two technologies will continue to play a significant role, in our energy system. But then the sources are not even in terms of how they operate. And we need something to be able to stabilize these sources. And that's how then the aspect of being able to use battery energy storage comes in very strongly. So if you look at the countries that have already developed their decarbonization pathways, Kenya, South Africa, Nigeria, one of the things that will comes out clearly is at some point, we need to include battery storage so that we're able to not only meet our energy demand, stabilize the grid, because we also need a reliable supply, which remains a major challenge in the continent, and also be able to support generally energy independence in terms of us moving away from depending on fossil fuels to be able to run our energy systems. So I think that's the reason why you will continue mostly going forward to hear about energy transition, and also having batteries come in very strongly to be able to decarbonize not only the electricity sector in this case, but also even in the transport sector and also the other sectors. Because if you look at it from a wider spectrum, we can even talk about cooking and clean cooking, and people being able to use solar energy for cooking. And in this case, you will hear the discussion of battery storage also coming in. So it means in all the segments of energy supply, we expect to see a bigger role being played by BESS, basically to assist, of course, in advancing access, to assist in enhancing our energy independence, to assist in decarbonization, and also improving on electricity reliability or energy supply reliability, which is a key component of development. Thank you very much.
Thank you, Nixon. Decarbonization pathways, BESS plays a major role in that, particularly now for the countries in Africa. We are going to need to deploy BESS to decarbonize. Let's shift gears a little bit and talk about economics. Of course, BESS cannot be deployed no matter how much of a solution it is, if the economics are not right. I'm going to invite Scott to tell us a little bit about BESS economics. Is BESS a viable option? What kind of returns do you get on BESS? What are the costs per kilowatt hours? And what kind of tariffs would you get on BESS? Scott?
Yes, thank you, Catherine. So on that point, perhaps I would start with maybe a note of caution. So ECA, we have done a lot of least cost planning studies, particularly across sub-Saharan Africa. And at least when you're working with an unrestricted least cost planning model, often you do find that BESS doesn't immediately emerge as a least cost option, at least in the short term. So it's not something that maybe emerges for another 5-10 years. And that's simply the case that while, yeah, we've mentioned that there have been some major advances in battery technologies, the costs have absolutely dropped at a great rate recently, but it is still, at least today, a relatively expensive technology. So with that in mind, though, on the margin, you would tend to find that if you start adding BESS to the system and finding a way of recovering those costs, it may raise tariffs a bit in the interim. Now, this does need to be compared to the wider economic value of better network performance, that you're integrating renewables, reducing emissions, and also potentially improving your delivery of ancillary services. And that's where, we've been in some discussions or some advice on that about how this is where you can make a case for donor grant funding to kind of help alleviate some of those immediate costs for maybe some startup pilots in the near future. And that's where these wider economic concerns can be captured within the wider economics, not just the finances of the individual project. Now, having said that, I would highlight a couple of key cases where the case for installing BESS can be strong today. So one is BESS is essentially often needed if you've got a renewables policy target. So there's more discussion about the energy transition and reducing our carbon emissions. And once you've kind of add those kind of restrictions to your least cost planning model, that's when you start to see BESS emerge. So once you've set those targets, we've often found with our planning models, you'll see perhaps there'll be a significant amount of solar capacity that is built, which leads to an excess amount of generation at midday. And that's where BESS does emerge as a least cost option for soaking up that excess midday solar, and then you can dispatch it at the evening peaks. And this is not just the case for solar. And we've also found this if it's a matter of BESS helping you manage the intermittency of wind, also the inflexibility of other renewable technologies, such as run-of-river hydro. And as we found in Kenya, there was a stronger case for BESS based on the fact that they have an excess of geothermal overnight today. So it's a matter of utilizing that overnight excess and shifting it to the evening peak. Another key advantage that needs to be stressed is the rapid deployability of BESS. So BESS can essentially be deployed in a matter of 1 or 2 years. As Tobias mentioned, grid stability services, which BESS is particularly well suited to, is traditionally provided by larger scale hydro reservoirs. But the problem is such projects, particularly if they're in the planning stage, they can have a very long lead time, so 5 to 7 years or even more. And similar issues can emerge when you're talking about network investments. So say if you want to build a new long distance high voltage transmission line, but there may be some restrictions on doing that too. So once you start accounting for those kind of issues and restrictions, your long-term energy planning results, it's not just a matter of, I guess the thing to stress here is not just a matter of pressing a button on a long-term planning model, such as with Plexos or whatever. You also need some stakeholder feedback to understand the true restrictions on the model, on the system, to understand where BESS can, be almost a plug and play kind of solution. Drop it in a year or two and you start solving some network issues today. So as Catherine brought up a couple examples at the start, but you'll see there's cases in California and Australia, very large scale BESS projects. And if you look at the timing of their announcements to their commissioning, often they're deployed within 1 or 2 years. So it's not just it's a reality of BESS as a technology. So having said that, just to touch on the issue of costs and tariffs again, you'll often see storage technologies quoted on a levelized cost of storage basis, so a cost per megawatt hour delivered. A note of caution needs to be made about you can't compare those figures directly with the levelized cost of energy that you often find for traditional generators. Because BESS's value, it really comes from its ability to shift energy across time to match supply and demand, as well as provision of network services. So it's not necessarily like for like with generators. Having said that, you may see costs, again, it depends on the funding model, it depends on the technology, the scale of the technology, how much you're using the BESS. And you may see quotes of about $200 to $250 per megawatt hour on a levelized cost of storage basis. But again, there's a ton of different variables that would feed into that. And aside of that too, it's also how you design your tariffs. So in the absence of active energy markets, or markets for ancillary services or capacity, as you may see in Europe, and that's where we see BESS technologies first came in provide those kind of market services in Europe. But if you don't have those, it's a matter of, well, making sure that you have a contractual model that properly remunerates the BESS capacity for the different services they provide. And within that, you can define, say, tolling fees, where it's an annual fee that just gives you the grid access to that capacity. Or you can go with the capacity-based fee. So that's where the charge is based on how much available capacity the battery provides. And that can also help you deal with the issue that batteries do degrade over time, or at least some technologies do. So then therefore your payments decline in line with the decline in the capacity. And again, just to maybe quote a random number of you, again, there's a lot of different factors here, but you may see tolling fees that could get up for a, say, 100 megawatt 1 hour BESS. Again, very, just some ballpark numbers here, but we're talking about 5 to 8 million a year, perhaps, as an annual tolling fee, or you could shift that to a yearly available capacity fee. And that's where maybe about 70,000 per megawatt, maybe less, a bit more. But again, there's a lot of different factors there. So again, it highlights that the costs aren't necessarily that cheap today. So that's where you can make a case for maybe some donor funding to support it, or maybe just work on some pilot projects. But it's also a matter of having the right regulatory setup for the tariffs to support BESS.
Thank you, Scott. It's quite clear from what you're saying that the modeling has to be done for one to arrive at the economic status. And at the moment, some donor support might be needed. However, BESS economics would then work. Let's get into a little more technical detail. I'm sure there are men and women in the audience who want to know. Tobias, we spoke about the use cases from the milliseconds all the way to the hours. Please explain a little bit to those who are interested, the people who are a little bit more technical, who want to know a little bit more detail regarding when is the millisecond, when is the primary frequency control, secondary, tertiary, when do you use black start, when do you use the load shifting? So if we get a little more technical detail with regard to those use cases. Tobias?
So, you hear me? You see me? Yes.
We hear you.
So it's a wide range already, and I just want to give Scott right. So I think it's an important point. You cannot really compare storage technology and generation units and renewable generation units. So it's a complete different type of operating ways and business models. So coming to the question of the time, yes, milliseconds is very often making the round. So batteries. So comparing with pump storage, we talk about seconds. So now we are in the milliseconds. Maybe the best systems can do around 150 milliseconds reaction to full activation. This is really complete different in new power to the grid, and really helpful in many systems, because these are the milliseconds that prevent the system for collapsing. So yes, frequency regulation, as told us already, they're looking for the very short term. And what is the typical layout of this? So in most countries, it's also required, or requirement of the grid code. So the 1 hour, so with the 1 hour duration, so you have 1 megawatt and a 1 megawatt hour system, or maybe a little bit more, is a quite common ratio and design in the most systems. So if you have a state of charge of maybe 50%, then you're able to react in both directions with full power around 30 minutes. And sometimes you put maybe a little more, 1.5 hours, so you have a little bit more flexibility in your own management. So, and where we are moving to, so as I said, in Germany, we already have covered the most frequency demand. So we have around 600 megawatt of frequency plus minus in the fast reaction sector. So this is covered by batteries already. So now there are new markets to look at. So we have the fast trading. This means trading up to 5 minutes before delivery. So short-term trading or intraday trading. So this is, and then you're looking what is the optimum size. So, or you can see on the market what is the size of battery systems they're building now, or where they're going to. So the biggest or the longest system now they're getting on the market is around 3 to 4 hours. So you can see where the market is and where the batteries are feasible. So they're getting longer durations. So they're looking for the peak shaving. They're looking for storage maybe for some hours, and then they can do the peak generation in the evening. And of course, it all depends on the cost per megawatt hour. It's still falling sharply, especially in the last month or in the last year or so. So I have to review all my business models from last year already, because the price is still dropping, and sometimes really in a way like 20 or 30%. So and at this time the client said always, okay, why didn't we have more megawatt hours? So you see the price. We have to change the model. We have to modify the system a little bit, so the battery is moving a little bit more in the 3-4 hours area. And yes, so I would say this is at the moment the optimum limit for cases. So midterm storage 8-10 hours is not feasible at the moment in nearly no market. And yes, everything we're talking about long-term storage, it's more in the future. Maybe the Redox flow or any other technology will be maybe able at one day. But if we're looking even with the forecast of the price for lithium-ion, it looks like that we're not moving in the really long-term storage possibilities. So at the moment, yes, most projects I've seen now and coming up, so up to 4 hours is quite a standard size. And then yes, moving from the frequency, and with also doing additional little bit trading or peak shaving.
Thank you very much, Tobias. So 4 hours at the moment. Let's talk about, we've heard about applications, we've heard of economics and previous projects. Anthony, generally speaking, what are the main barriers to deploying BESS in our region at the moment? And how can some of these barriers be overcome?
Yeah, for the longest time, cost has been a big barrier, but as we've heard, costs have been declining quite significantly over the last couple of years. So really, that is not a real barrier, so to speak. In any case, where you do find value of the services provided by BESS, outstripping the cost, then really cost should not always be the barrier in there. But as we've also heard, batteries are not always the least cost option, depending on what application you actually want to deploy them to. So yes, cost then in some aspects then becomes a limiting factor. I think the next barrier that we have is really around technical capacity, capability, and really just being able to match the use of the battery to the use case that is intended for. As you've seen, there's quite a wide variety of ways that you can deploy BESS in a system. And lack of capacity, understanding, knowing for which application do you want to deploy the BESS for? Is it the most suitable? Is there experience in doing that? That is definitely still a challenge, albeit reducing with a lot more experience and the mobility of battery storage expertise across the world. We do have, like on this call, a couple of experts, as you've seen from the panelists from across the world, who've deployed across various applications and scales. So I think slowly that is stopping to become a barrier, but it can still be quite something. I do think at our utilities, at our policymakers, at our regulators level, sometimes you find there's not much understanding in how to really deploy batteries, how to really price, how their value, and so on and so forth. And as a result, what we tend to see is a little bit of inertia in deploying batteries, because there's a bit of I'd call it path dependency, because you do have legacy assets that are in the system. For example, in Kenya, we do have geothermal in place, and the tendency would be to say, okay, can we provide ancillary services using geothermal or hydro, as the case may be, or even a couple of the thermal plants that are available. So I think path dependency, legacy assets, combined with lack of understanding from a capacity capability perspective, and just that marginal incremental cost of deploying the technology can really lead to slow uptake and form a quite a formidable barrier to deployment of BESS in the system. I think coupled with technical capacity, capability, quite closely related there, could be the issue of uncertainty. Different battery technologies, battery chemistries, or even batteries from different OEMs do have quite a big variability in degradation profiles, safety requirements, warranties, and so on and so forth. So it can be quite confusing if you are trying to deploy a battery and trying to assess your use case, trying to look at all these details. Is it a 10-year, 15-year, 20-year profile? What's my degradation going to be like? What's my utilization going to be like? What penalties coming? Say from an operator, should I cycle the battery more than the manufacturer's degradation profile, and so on and so forth. So that can cause a bit of reticence when it comes to deploying BESS in our systems. But I think the more important one for me, the most significant challenge today is really market structure. So you typically have markets that value power more than energy. Batteries are neither a generator or a transmission sort of equipment. So when you have a market structure that does not incentivize battery operators or battery owners, then that becomes the biggest impediment, because then you have to start thinking, how will I actually get compensated? How will my services be valued? And how do I actually build a business case that then supports my ability to finance this project? So I think in Europe, North America, and other markets across the world, we started to see energy markets that do value battery storage, putting in capacity payments, tolling payments for energy services. Even I think now we saw earlier on in Kenya, I think in February, there were regulations that were published by EPRA that talked about an ancillary services market and potential to get an ancillary service license, but we still don't know what the framework for compensation looks like. So I think, to me, that today is the single biggest hurdle to deploying BESS in Kenya, especially when you're talking about deploying it at the utility scale. Thank you.
Thank you so much, Anthony. Market structures, the framework for compensation, especially for utility. Thank you very much for that response. And that brings us smoothly to the regulatory landscape and how are regulations evolving to accommodate advancements in BESS technology. I would like to invite Nixon and Scott to comment on this answer, the regulatory landscape and how it is evolving across Africa, across the region, and particularly in the EECA countries. Nixon, you want to go first?
Okay, thank you for the question, and I think Kumburu has already tried to address some of the issues that are coming up in the markets. And just to say, the ECA study that was funded by World Bank really tried to discuss some of these issues, especially for a country like Kenya. But then looking at it from a continental perspective, one would be whether the system, the market structure itself, the regulatory framework, the policy framework actually does recognize battery as a form of service in the market. And then actually, even before thinking about the battery itself, whether auxiliary services is a service that is either recognized or appreciated in the market and compensated for. Because you'll find in most of our countries within the region, still the market is either vertically integrated with one player, of course, with the government controlling most of the stake. And in this case, then lumping the entire electricity services into one package. And when you look at even some of the power purchase agreements, you'd find they do not recognize payments separately for auxiliary services, which I feel batteries will actually it will be the first entry point for batteries into the market, because we realize we need to improve on electricity reliability. And therefore, to be able to do that with the integration of more intermittent sources, then we need to have some form of auxiliary services to support the system operator. So that also comes out with the issue of who owns the batteries that are to be integrated onto the network. So that's one of the things that also that should be addressed. For some of the countries, Kenya, Germany initially, they did not recognize or allow the system operator to be able to own, to be able to participate in the market in the form of buying and selling of electricity. So it means the regulatory framework that is being established has to address this issue and maybe redefine. And this has been done in the European Union. It has been done in the US, in the state of California, trying to redefine and have a place of battery storage itself. And also, if we have a market, or a market where you're able to buy and sell electricity in real time, in this case, then allowing some proportion of this market to be contributed for by a battery storage, because then you'll be creating that demand for the systems themselves. So then, in addition to that, the regulatory framework will also be able to speak to how the process of licensing is. Basically, if you want to set up BESS in Kenya or in the region, what do you go through to be able to get that? And we'll find in some of the states, they have even tried to, some of the countries, they have tried to reduce some of the regulatory requirements in terms of the requirements to obtain land, to just make it easier for people to be able to set up BESS in the market. Of course, the normal other aspects of licensing, like environmental requirements, the technical and economic performance also come in. But then in this case, the question would be, would we be looking at BESS as in relative to other sources of energy, or do we have objectives to ramp up that BESS and maybe set up some targets for BESS, depending on the specific requirements of the systems that we are operating. So if you're looking at the regulatory perspective, one is, just to summarize, is the administrative aspects of the market. So licensing, approval, ownership. Two would be the market structure itself. Who owns BESS? Is it the system operator? Will it be amortized as part of the assets that are owned by the generators? Do we embed it to some of the plants, the intermittent plants that are, for example, have solar with the storage, wind with storage? And if that is the case, so how do we compensate for that? And when these assets come in to support the network, for example, for black starts, how do the players in the market then get compensated for those services that they have? So one is to recognize battery storage as a service. Two is to take into account the different operational characteristics of the technology and what it can be able to provide in the regulatory framework. Three, of course, is to provide a mechanism for compensation. People will invest. We expect investors to come in and invest in this technology. So how are they going to be compensated? Are we going to pay for the capacity in terms of availability? Are we going to pay them for arbitrage, which of course is not realistic in most of our countries in Africa, because we already do not have a market. So I cannot just set up a plant in anticipation that the system operator will need me at some point. And that's where we'll find most of our markets bilateral contracts between the system operator and in this case, the IPPs, and also even other government entities. Even for bilateral contracts between countries, you have seen most of them are coming out for contracts between countries. Most of them are initially coming out as bilateral contracts. So then how do we structure our market in a way that we can be able to accommodate? And of course, the last aspect would be the issue of which charges will be applicable to someone operating BESS. Would, for example, will you be required to pay taxes when you are charging and discharging your battery? So some of these issues have to be looked at in the market then to be able to facilitate growth in the industry. So ownership of the infrastructure itself, recognizing BESS and its services, being able to look at the compensation mechanism and the approval process are some of the things that the regulator should be able to look at in order to enhance the uptake of BESS. Thank you.
Thank you so much, Nixon. It's quite obvious from your answer that there's still quite a bit of work to be done around the regulatory structures. Scott, do you have anything to add?
No, that was some excellent response from Nixon, actually, and quite comprehensive. So I'm not sure I necessarily have that much to add, but I can maybe just to try to quickly distill it. It kind of gets to the regulatory question of is BESS a generation asset or is it a network asset? And that's ultimately a question for the regulator, if you will, and it gets into questions of if it's a generation asset, you maybe have to define some sort of contractual arrangement. Similar to designing a traditional PPA that recognizes the different remuneration that is needed to compensate a BESS for all the different services that it can provide. So the so-called revenue stacking model, as they call it. Or do you embed the BESS within your network and then the costs of it are recovered through your network tariffs? There are pros and cons to each of those, but essentially it comes down to, do you set up kind of a storage contractual agreement? So in the absence of having an active spot market or active markets for ancillary services or capacity markets, you can kind of bypass that a bit, especially if you're waiting on the regulatory framework to be established. You can just set up a storage contractual agreement, which would be between the BESS owner and the buyer, and often the buyer in this case would be the system operator. Or if you treat it as a fully regulated network asset, and that's where then it would just be recovered through network tariffs. So again, partly repeating some of the stuff Nixon was saying there, but he had a quite good comprehensive response there.
Thank you so much, Scott. Generation asset or network asset, something to think about. We are running out of time. We are almost at the end of the panelists, and then we move to the Q&A. I would like to invite the panelists to look at the questions. We have at least 17 questions. Please look at the ones you can answer because we want to give value to our listeners. We don't want to spend too much time. Look at the ones that you are able to answer so we can have about each panelist answer around 3 questions in a quick fire as we move towards the end. Now, Scott just spoke about generation asset or network asset, and I want to talk about power energy combination. You often hear megawatt, megawatt hours, megawatt, megawatt hours. Tobias, please tell us, what is the sweet spot for sizing? Is it better to have a 1-hour system, 2-hour, 4-hour autonomy? Which of those systems is the best in your power energy combination? Tobias?
Yes, seems like a easy question, but I have to be honest, I cannot say this. I have to depend on. So just to give you some ideas or some parameters you have to take into account. So the total grid, so the configuration of the grid, how much gas, how much coal, how much hydropower. So the load profile as a fluctuating demand side is quite important. So you have the peak generation, when it's the peak generation, and how long. So of course the share of renewable energies, this is one of the key parameters. And then of course, what type of renewable energies do you have? What is the profile of the wind? What is the profile of the PV? Do you have hydros? Do you have big reservoirs in the background, and so on? Geothermal is the point. So, and then of course, what kind of grid do you have? Is it interconnected to other? Do you have import, export? Do you have exchange? And then all the 3 points of cost. So what is the cost of the conventionals? If they're very high, storage became much more feasible, even at the behind the meters. So what is the cost of the renewables? So if you get PV for less than 5 cents, even for private consumers, it really can make sense to just store by themselves or even in a larger way. And then of course the cost of the storage itself. So what is the cost of the power megawatt? What is the cost of the megawatt hours? And especially regarding batteries, it's just not the cost. So the lifetime is quite important. So if you have a battery that have a life cycle 3 times than the other battery with the same cost, it's 3 times more feasible in an economical way. So many factors, and yeah, what I said, sweet spot really don't exist. So as I said, frequency regulation 1 hour is the standard, working well. Everything on short term a bit between 2 and 4 hours, and yes, everything about 4 hours at the moment not really feasible, but I think in the near future we are going far beyond those 4 hours. So all depends on the cost and all depends on so many factors. But yes, I just try to give you some easy definitions. Or
thank you so much, Tobias. So there's no magic number. One just has to model to get the right size. Let's talk about financing. Anthony, where do we get the funds to deploy BESS? Where are the investors? What kind of funding is available out there for battery energy storage systems?
Yeah, interesting question. I think to me, it first comes back to a market mechanism. I think if we can solve the issue of a compensation mechanism, a market mechanism that allows compensation for the services that BESS provides, then the issue of financing then stops being a big issue, because once a market exists and there is a predictable way to value the services of that battery and a predictable guarantee on payment or how that value will be compensated, then capital naturally will flow into financing BESS. So I think to me that's the first step. Then the second question is really around who's looking to finance. What is your role in the system? Are you a utility? Are you a project developer? What are you? Are you TSO? Are you a system of and so on and so forth? So depending on where you sit in the system, then you obviously now have either project financing, the typical project financing models available to you, or you do have on-balance sheet financing suddenly being attractive, because you can actually accurately now quantify the value that you will derive from BESS as an asset. You can depreciate, you can amortize, and that becomes easy for you to then attract financing. Financing then, to me, in that case, becomes nothing too special from any other energy asset financing, whether it's a power plant, whether it's a transmission line, and so on and so forth. So I think the real answer for me here is financing is available, but financing is dependent on a clear mechanism for compensation being available, because as a technology, batteries are quite mature and rich. There's a rich portfolio of batteries deployed across the world, and we had even in this webinar's introduction session. Lots of large-scale batteries across the world, different operators, be they utilities, be they developers. But the crux of it all is what market structure exists to really support value creation. Then capital naturally flows. Selfishly, I'd mentioned at EDF, we have financed quite a number of battery storage projects. We're currently involved in the South Africa battery storage system. So I think yes, it is available. Can be project finance, can be on balance sheet finance. We can be DFIs, but really for me, the financing really needs to follow on once there is a credible market offtake system that actually guarantees investors that they will actually, and financials for this case, that they will actually derive value and they will actually see longevity and some sort of de-risking and certainty in the value flows from deploying a battery system.
Thank you very much, Boro. And you say where there's value, finance follows value alongside the structures. Very well put. Now we are down to our last two questions. And as we do the last two questions, I would like to invite Engineer William Madara to be on standby after the last question to make some remarks for USAID, who ran this program, before we go to the Q&A. The questions are increasing as we move towards the end. Panelists, please look for a few questions which you'd like to answer, because I really want us to tackle as many as possible. I don't want to spend too much time. I may read 2 or 3 as you respond. Nixon, does BESS have any role in regional power trade? Regional power trade is one of the objectives of EECA or Africa, And so I'm just wondering, I've seen some reports on under frequency load shedding and over frequency load shedding, and I was just wondering if BESS has any role in enhancing regional power trade, given where you are seated.
Yes, I would give a big yes, because we are looking at how we are able to enhance our system integration, and that's why you'll hear most in the African Union us talking about the Continental Master Plan and being able to develop our policy, regulatory, and standards in a way that we're able to support each other's grids. So in this case, I would say an asset, for example, developed in Nigeria for BESS can easily serve Ghana if it's planned together. And I know in Europe, in the European Union, the examples of storage, traditional storage before the use of pumped hydro to support the grid, not in one country, but also in the other countries surrounding that. And I remember at the beginning of this discussion, Mburu did mention the aspect of BESS being able to support the transmission network, so defer upgrades of investment to be able to support the network. So it means if, for example, Kenya is interconnecting with Tanzania, which we are doing now, and then there is a constraint on the network in terms of capacity, it's possible to use BESS to defer that investment and allow use the BESS then to allow evacuation of power through that line without necessarily doing investment in terms of upgrading the line. So from where I sit, we are embracing and we are really pushing for having integrated planning in terms of our energy systems. Instead of a country, for example, Nigeria or Algeria, planning for itself, but also trying to look at what are the needs of the neighbors, because it's not just in BESS as a technology only, but also our neighboring countries have different profile of resources. So you'll find a country in Congo has a lot of hydro, which the neighboring countries can easily benefit from in terms of energy, in terms of auxiliary services. So if you can be able to utilize that resource, then the neighboring country might not need to invest in BESS. So it means they can plan together. But in a case where you don't have, and there are many examples in the continent where countries do not necessarily have spinning reserve resources like hydro or natural gas, then it becomes necessary to plan together in terms of how you are going to balance the system as you go forward. So we need the sector reforms for sure to make that possible, because over the years we've been operating in isolation. So we need to undertake internal reforms in our member states, and also look at those reforms and how they can be able to support the regional market, not only for energy, but also for auxiliary services. We need to develop the regional master plans. Of course, we have the regional master plan for example, for the West Africa region, for East Africa region, some of them which were developed 10 years ago and beyond. And we need to look at those master plans so that then we can be able to accommodate the new development and the new technologies that are coming in. We also need to, as I've already mentioned, to optimize the availability of resources that give us the different characteristics that you can be able to use in the network. And just to give us an example, I think I was reading one of the reports by McKinsey, and they were saying if, for example, the United Kingdom continues to operate in isolation from the European Union, the projections are the amount of battery storage they will need in their network would be more as opposed to if they were still with the European Union. So it's just an example of how regional integration can then assist us to defer some of the investments and the need for us to be able to continue working together as member states in Africa. Thank you.
Thank you very much, Nixon. Much appreciated on the regional power trade and BESS. I would like to invite our host to upgrade Engineer Badara's status to panelist, even as we tackle the last question, to allow him make some remarks ahead of the Q&A. Last question is the million-dollar question. What is the future of BESS? And to answer this question, I would like to invite Scott and any other panelists to add to what Scott will say. What is the future of battery energy storage systems? Scott?
Big question, Catherine. But yeah, I'll take a shot at it. And I think some of it will very much be touching on some of the previous themes we talked about in terms of the development of technologies over time. And I think it's one of those things, every time you dig into it, it's an exciting field. There's so many different storage technologies you read about that are currently either being researched or in the pilot stage. They have different characteristics in terms of the scale, both in power capacity or in energy capacity, the duration, cycle rates, etc. So it's definitely it's something that we'll be developing over time and is worth keeping an eye on in the latest technological developments. And the appropriate technology ultimately will vary by system and the needs of the system. So often you'll find electrochemical technologies as lithium-ion batteries that currently dominate due to their economies of scale. And they're probably going to be the way to go in terms of shorter duration storage, in terms of 1 hour, 2 hour dispatch or providing ancillary services. But then also there's increasingly looking for solutions for longer duration storage. So often traditionally provided by pumped hydro, but there's kind of limits essentially geographically or geologically with respect to new pumped hydro storage projects. So there's a number of different technologies being trialed there. Something we've been looking at quite recently with some modeling in a wind-dominated European market, where they're quite concerned about what happens when you've got, say, 1 or 2 weeks straight of low wind dispatch, and what do you do with that? And that's where you might have to embrace perhaps lower efficiency in terms of the round-trip efficiency of the technology, but allowing for a longer duration dispatch. So you see that with some examples in compressed air, flow batteries, molten salt. There's a few of those examples. So I'm not an engineer myself, so I can't talk necessarily about the technological specifics, but it's something to keep in mind for the longer term modeling. And that it does raise quite a tricky debate for emerging markets, is whether you kind of wait for more developed markets to kind of pilot and trial new storage technologies and maybe wait for cost to drop a bit further. Ultimately, say there's a trade-off there, because as I mentioned earlier, you can use BESS to solve some grid issues essentially today or within 1 or 2 years that for other technologies might be some barriers to. So that's where we've made the case, at least that's where you maybe hopefully get some donor-supported projects, some pilots to kind of assist with that short-term financial viability and then kind of see how the technology develops over time. And maybe as a final bit, I think Tobias kind of mentioned this himself earlier, that very much, at least in the phases of how you saw batteries develop in Europe, America, Australia, very much they were concentrated on providing ancillary services. And that was where markets were specifically designed to take advantage of the millisecond response time of batteries. Having said that, those markets are now essentially saturated. They're quite competitive, and that's where battery developers are now looking further afield. Okay, what's the next best way we can solve issues on the network? And that's where you're seeing an increased importance of energy shifting for managing renewables intermittency. So just to give you an idea of the scale here, I was just looking at the UK National Grid's latest scenarios, looking at the 2030, 2050, and they're talking about 100 to 200 gigawatts of wind and solar, and that's just the UK, being built over the next 25 years, and then needing about 25 to 80 gigawatts of power capacity and 130 maybe gigawatt hours or more of energy capacity from storage. So just in terms of the sheer scale of having to manage that much of intermittency, it can't be stressed enough that it's going to be quite large. So having said that, then some grids are finding that once they've kind of saturated those grid level ancillary service markets, that's where they start actually getting into more of the location of BESS. So it either becomes with co-locating BESS with renewables to help kind of manage that intermittency and storing when the grid is congested, or it's a matter of the placement of BESS so that it can itself help reduce network congestion and reduce the needs for network investments, as just the scale also of network investment of this is becoming a growing concern. So if BESS can help you reduce those needs over time, I think there's definitely something where the electrical engineers are putting their heads together to try to figure out how to best locate BESS on grids.
Thank you, Scott. Thank you so much for that future. Anyone wants to add a different perspective on the future of BESS? Any of the panelists? Okay, great. Thank you so much for that very those insights, our dear panelists. It's really, really been educative to have this session. I'm told William is not available at this point. So I just want to recognize USAID again and Power Africa, who are behind this program.
Hi, Catherine. Can you hear me?
William, welcome. Welcome. Karibu. Can hear you loud and clear.
No, thank you. Thank you so much. Yeah, a big thanks to our panelists. This has been a very, very informative session. I've been glued to it since the beginning. And at the start, I did a bit of just looking for information, existing information on battery storage in sub-Saharan Africa and the world. And I came across an interesting bit of statistic. Last year, 2023, there was almost a tripling of the capacity of battery storage constructed across the world. 45 gigawatts of new battery storage facilities were constructed across the world only in 2023, bringing to the total to something like 60,000. I don't know how factual that may be. The panelists can correct me if I'm wrong. And this year we expect also another 45 to 50,000. Now, looking at Africa, outside South Africa, we don't have even 1 gigawatt of battery storage. And listening to the panelists really outline some of the requirements for battery storage, some of the issues required for legal regulatory framework, issues about the structure and the pricing. It shows that there's quite a bit of work required to be done in sub-Saharan African countries, because these are the countries with quite a lot of resources. Wind and solar energy resources are amongst the best in the world. Electricity access is still quite low. The existing utilities are still not financially viable. The tariffs are still not yet fully cost reflective. The government still want to control the tariffs. And so these make it a bit difficult for the private sector to come in. Again, do we look at battery storage as an additional capacity to the system or as energy? Does a utility buy electricity from a generator, have capacity with capacity payment, and again buy the stored electricity from, say, a battery operator? So those are some of the serious structural issues which need to be addressed. And listening to the panelists helped me understand and see the amount of work that needs to be done. One thing I would maybe like to hear more about is, given the kind of setup we exist in, given the kind of structure we exist in, if we look at Africa, can we push more in a situation where the developers of renewable energy are the ones who come with battery storage, so that all this is structured as the first step of getting sub-Saharan Africa to basically improve its energy situation, reliability, and security going forward? That is one thing I would maybe like the panelists to speak about. But other than that, mine on behalf of Power Africa is to thank all of you for taking time to just share with us this important topic, and to also inform you that we will be carrying out a lot more of such energy cafes on topical issues. It is very important that we get talking. It's important that we connect together the different players to just try and discuss and come to a consensus on some of the issues which exist to help meet the electrification question in sub-Saharan Africa. Once again, thank you so much. Back to you, Catherine. Over.
Thank you very much, William. Thank you for your remarks. And it's good to note that we're talking 45,000 megawatts and another 45,000 megawatts in the next year. I would like to invite one panelist to answer William's question before we progress. Who wants to take that? Nixon? Did I see you on mute? Thanks.
Yeah, maybe I could try. I know it's a difficult question, but then it's more of looking at what is provided for, one, in the grid codes for the respective countries and also for the region. And also then from the grid code, being able to specify some of the conditions in terms of, for example, the required spinning reserve that should come with capacities of different capacities of wind and solar projects that come into the network. I remember there's a time we're looking at when we're looking at the auxiliary services market in Kenya years back, I think 2 years back, we reviewed some of the grid codes, and I think in South Africa, if I recall well, they were saying if you have a 50 megawatts power plant and above, then you should be able to come up. That plant should have some form of spinning reserve or way of being able to contribute to spinning reserve. So I think being able to have such specifications in the grid code, and of course having them enforced, will then actually support the development of these technologies with batteries. And also it will give a good indication, because it's a question I've always had before. Of course, I promote the uptake of renewable energy, but then when we're looking at the actual cost of, for example, having 100 megawatts wind power plant or solar power plant in the grid, we should also maybe include the cost of reinforcement required on the network to be able to meet the system requirements. So if I put 100 megawatts, how much extra spinning reserve or BESS do I need? And that aspect of having the two conjoined together then assists us to address some of those issues that keep coming up, where people say it's not just the power plant itself of 50 megawatts wind, but then I also have to invest an extra amount to make sure that I'm able to operate that power plant on the network. Thank you. I think I will stop there because of time.
Thank you very much, Nixon. Really appreciate that response. I would like to read 3 questions real quick to enable the panelists answer other questions. There's a question by Charles Baliohere. I would like Nixon to answer this question. I'm going to read all 3, and then you'll answer all 3. Nixon to answer. Charles, how does the transition to electric vehicles play a role here? Is Africa not at risk of becoming a dumping ground of batteries that have expired elsewhere? I know that here in Kenya, the regulator really put in place the requirement for licensing before somebody can deploy solar PV. And so the regulator has done something around avoiding dumping and substandard products. And that's why I'm inviting Nixon to answer that question of the risk of dumping ground of BESS in Africa. The second question will come from Murefu Barasa. I suggest that Tobias answer this question. Tobias correctly pointed out that direct comparisons of energy from BESS to generators may not be entirely accurate. Bloomberg expects battery pack prices to fall to below $100 per kilowatt by 2027. How does this compare in terms of BESS energy to generator energy? Last question that I'm going to read out is from Guy Dixon of Milele. I request that Scott answers this question. Where does the panel see BESS being located in East Africa? Kenya, perhaps? Scott did do the pre-feasibility with the World Bank, and he may be better placed to answer this question. Is co-locating with VRE, with revenues baked into PPA, less efficient than central transmission? Grid locations with its own ancillary revenue sources? Scott, if you could answer that. Let's take it from the top. Nixon, Tobias, Scott.
Yeah, very briefly, I think for the batteries and dumping, that comes to setting up of standards. I know for most of our countries, most of our standards bodies have come up with standards on these technologies and how then to prevent. The actual thing now is to enforce those standards to prevent the entry of used batteries or refurbished batteries into the market. I know it may not be a major challenge for big utility scale projects, because then some of the options that are being looked at is to have actually the manufacturers themselves being able to operate the batteries and provide it as a service to the system operator as part of the options that are being looked at. So maybe for the smaller systems, that's a serious challenge, but then the standards do exist for you to be able to enforce that, for you to stop that. The only key thing then that will be required is enforcement and also disseminating information on where to get good quality batteries and why you think we think good quality batteries will be a good thing in terms of advancing developments in the market. So I think also with the permission of Catherine, I will mention one thing on one of the questions asking about how can Africa get 100% renewable energy, utilize 100% renewable energy? In my view, well, we have the required resources in terms of the energy resources. We have the critical minerals that we in the continent. If we had time, statistics on that. If we're able to utilize these resources well, we can be able to transition to 100% renewable energy. But of course, also working with the different fleet of generation sources that we have in the different countries. So if a country has more hydro, then taking advantage of it, and also then complementing it with the intermittent energy sources to make sure that our grids at regional level or at continental level are more renewable as compared to what they are now. Thank you. I'll stop there.
Thank you very much, Nixon. Tobias?
Okay, regarding the price forecast we have here of $100 per kilowatt hour by 2027. So this may, so just in general, be careful with forecast, of course, but this may be a realistic number. But also be careful with the price itself. It's just the price for the pack. It's not the price for the complete system. So if you have a complete BESS, you have to include the inverters, the transformers, the high voltage transformers, the connection, the site preparation. So maybe realistically we can reach the 300 per kilowatt hour for the total large grid scale. And you also have to take, or always have to have new the parameters. What is the lifetime of this? So a cheap battery with 5 years, or you gotta, or can this 100 kilowatt hour last for 20 years? So always keeps the whole picture. So yes, realistic number, but yes, just see, it's just a pack price.
Thank you, Tobias. That's just the pack price and not for all the peripheral BMS and power conversion. Thank you, Tobias. Scott, on Guy Dixon's question.
Right. Yeah. So this is generally a question about locating BESS, really, and Guy brings up the example of Kenya, where we just done some work. I guess there's a few different angles you can look at for location. So one, as I was just touching on, that increasingly, at least in some of the European markets we're looking at, where originally there was very much a focus on grid scale, grid level, transmission level, and ancillary services provision. But once that's been saturated, well, there isn't necessarily more marginal value to adding more capacity to provide that those ancillary services at a grid level. So that's where you get in kind of more taking a step down, finding where on the network can you also place the BESS to kind of help relieve some existing network congestion constraints. And that's what would require then ultimately the work of a network engineer to kind of look on the system, what's realistically getting developed, and where maybe placing BESS can help you either defer or avoid some network investments. Secondly, because I think, the question touched on how co-locating with renewables might make a PPA less efficient compared to central transmission. So one that goes back to, it depends on how much ancillary service need provision there is needed at a grid level. So potentially they're saturated already, and that's where then there really isn't much more value to it anyways. So you might as well co-locate. But if you also have a system where that is desperately in need of more ancillary services capacity, then maybe that's where it would kind of lead you toward placing the BESS somewhere that helps the transmission system at large, rather than firming up the dispatch of intermittent renewables. But having said that, it doesn't necessarily make a PPA less efficient, if you will. It could, the other side of it, you could look at it that it can firm up the capacity offered by PPA. So if you're saying that you have a 100 megawatt wind farm, but you might have to derate that to account for its intermittency in terms of the PPA. But if you add a co-located storage, that may firm up so that you can get closer to saying that you are providing 100 megawatts in your PPA. And finally, I would just say on almost a practical level, this is something that we were finding in Kenya. A lot of it came down to, well, what land is available, or at least freely available. So those were some discussions with the utility in terms of if they had to spend some money just to kind of rent out or purchase some land to place the BESS, or potentially they've got some space already near an existing substation. And that's where, as we kind of touched on, well, cost is such a sensitive issue for BESS. If you can lop off some costs, reduce the cost a bit just from avoiding rental or land ownership costs, that can in some ways be the threshold that actually tips you over to, well, it's best just to use what land is available rather than worrying too much about network congestion or transmission level ancillary services.
Thank you very much, Scott. So I am afraid, audience, we have run out of time. I thought 2 hours was a long time, but it has moved by really quickly. I would like to invite the panelists to prepare their half to 1 minute roundup, final words. I would like to thank everyone who worked hard to put this together. First up is the Power Africa USAID team members, led from the side of Engineer William Madara. Then the Power Africa and Power East and Central Africa team, led by Dawi, the entire team from East and Central Africa and the Home Office in the USA. I would like to thank our panelists for creating time to join us today. They have given us a wealth of insights. I'd like to thank the comms team for all the extra work they put into it and the small committee that sat together to look into how we can run this. And most of all, I would like to thank you, our audience, for joining us today. I can see there are 21 questions here. 12 have been graciously answered by our panelists already in terms of putting into the Q&A responses. Taka, Neshati, with Africa Energy Legislation, Micheni, with utility scale sizing for ancillary support, Devin Bogwa, thank you so much, Charles. We did answer one of your questions, Sabina. Most effective strategies to attract more investment, Odhiambo Odawa, thank you. Yes, we shall share the resources. Elijah, influx of fake substandard batteries, noted. Murefu Barasa, we have answered. Farah, grid scale BESS and renewable energy. Yes, we have spoken about that. Guy Dixon, Joel, thank you for all the amazing presentations. Why is it still challenging? We have answered that. Fiona, reactive power compensation. We can talk about more about that in future meetings. Charles, okay. Peter Baldwin, will there be a copy of the presentation? Yes, that will be shared. Charles, excellent suggestion by William, thank you. It ought to be a mandate of planner and not operator to ensure BESS and so on are in place. Charles, that's Charles. And finally, Fiona, what effect does BESS or frequency control have on battery life? We're going to discuss more about that in future, Fiona. That is in the detailed training. So thank you very much to all our audience. We really value you. Thank you for joining this conversation. We hope to interact with you in future. And we are going to share the resources. I would like to invite the panelists now to give their very, very brief closing remarks. We respect your time and we want to close at the top of the hour. Let's start with Scott, then Anthony, Nixon, and we close with Tobias.
Right. Oh, thank you, Catherine. Yeah, I think just the few points I would make. While there's definitely some short-term cost challenges to BESS, that is a fast-changing field. It's vital for the energy transition, and that's going to keep on changing. The costs are going to keep on coming down. So with that in mind, a key point I would generally stress is learning how to include BESS technologies as an option when you're doing integrated generation and network planning. So this requires utilities, regulators, energy ministries, all together to get familiar with some of the associated legal, regulatory, and modeling issues and grid requirements that we've been discussing on this panel here. While it can be a bit intimidating with BESS, that it's a few different aspects to account for when you're talking about energy capacity and storage volumes and ancillary services, et cetera. But it's a worthwhile and quite interesting field to get into and understand how it can contribute to network development. Thank you, everyone.
Absolutely. True, Scott. I agree with you totally. Anthony?
Great. I think 6 years since starting to work on BESS, I think we've come a long way. It's quite exciting to be having these kind of conversations. And I think I do agree that, it's time we really saw more BESS projects at utility scale beyond South Africa. I think the space remains an evolving one. The technologies are improving. If you look at things like lifetimes, cycles, warranties, 8-10 years ago, vis-a-vis today, the variety is quite large. And I think the other thing I probably like to say is BESS is not a one-size-fits-all solution. So you cannot really take one use case and try to apply it to a broad range without really studying, how you want to deploy it, what's the right BESS. Is it a short duration BESS? Is it a long duration BESS? Are you looking for power? Are you looking for energy? Are you looking for longevity? Are you looking for and a lot of cycling? So there's a lot of intricacies that sort of go into that. So yes, understanding your use case and engaging with the professionals on how to actually deploy BESS is actually pretty useful for anybody who's considering BESS. And my parting shot is that you cannot really talk about integrating variable renewable energies, solar, wind, without really considering some sort of energy storage on any scale. So thank you very much, Catherine. That's really what I had to say.
Thank you very much, Boro. It's not a one-size-fits-all. You have to model each time to arrive at a solution. Thank you very much, Boro. And yes, we have been doing BESS with you for 6 years and over. Nixon?
Yeah, first, thanks to of course, to Power Africa and to the audience for hosting us and also for listening through. I'll just be brief. I say, one, we need to power Africa for sure. The African continent needs power, needs electrification, needs access to modern energy services. We need at the same time to industrialize. And at the same time, we also need to look at decarbonization as one of our objectives. As a continent, we do have the necessary ingredients in terms of the available renewable energy resources from wind, hydro, solar, geothermal, and all the resources that we have in the continent. We have the ingredient in terms of the natural resources and the critical minerals that we can be able to use, for example, to even manufacture BESS within the continent. We may need, of course, to move away or move forward, move a step further, just to not talk about the use of BESS and its applications on the network, but also how we can be able to take advantage of the critical minerals that we have in the continent to produce or manufacture these technologies locally. For this will surely make it affordable and easier for people to be able to adopt them. So I'll stop at that. Thank you.
Thank you very much, Nixon. And we have to figure out how to make it affordable. Last but not least, Tobias.
Yeah, I'll make it short. So it's just regarding the development of BESS we just seen in the current days and the forecast we're looking for. So especially for Central and East Africa, I would say from a European view, if we would have so much sun and a really quite constant sun radiation available, together with batteries, I really see a high potential, because this is now moving in this daily balancing, and I see really high potential for a high renewable energy rate, looking at the numbers for PV and for BESS, and I think this will be a perfect match. And yes, all the best.
Thank you very much, Tobias, and thank you for the best wishes. So we've come to the end of our Energy Cafe, charging ahead with BESS. We are charging ahead to a carbon-free future. We have seen the numbers, 400 gigawatt hours by 2030. We really have to be part of that space as we charge towards a carbon-free future. Our social medias are on hand. Please follow those to learn more about the work that Power Africa does across Africa. Power Africa is making a difference. Thank you so much for joining us. I wish you all the best, and I look forward to interacting with you in future sessions and as we continue doing this work of reducing energy poverty and increasing energy access. I would like to wish everyone all the best as we break. Have a good day, have a good evening, whichever part of the world you are. In Kenya, we say, asanteni sana. Bye. To our panelists, thank you very, very much, and look forward to engaging with you in future activities. Kwaheri.